Okay. Mr. Beaujolais is coming. That's what you mean. Ready? Okay. So if we divide this equation, by the way, where did this equation come from?
Last chapter?
It's
the equation of what? It's the equation of a circle. Right. Okay. Okay, which also comes from the Pythagorean theorem. We know that. We studied it in geometry class. Okay. What if we took this equation of a circle and we divided by r squared? Dun dun dun. X minus h quantity squared over r squared plus y minus k quantity squared over r squared equals, we'll go back to 8.1 after we get done with 8.3.
Why?
Is one of the variables in our equation. All right, now what's on the other side here? 1. What do you notice about both of these denominators? They're equal to each other, aren't they? They're the same, aren't they? That has something to do with this being a circle. What happens if those numbers are different? It makes a squished circle, which we would call what? Do not use the term oval in this room. Ellipse. Thank you very much. Okay. Oh,
Wait,
seriously.
is it the ellipse in the other word that says any ellipses, those three dots?
Okay.
The O word?
We'll give you the definition of that. So, if we divide them by different things, so we have x minus h quantity squared over a squared plus y minus k squared quantity squared over b squared equals 1, we have an ellipse. Okay. It's only a circle if a squared and b squared are identical. Oh, well, no, not quite. All right. How did I get them? They just have to represent different values. Okay, we just use the letters A and B. Scrolling. I think that's what you meant. I scrolled down, but which way is that what you meant? Going up?
Well, no, you go up on the page.
Is that what you wanted?
Yep.
Okay. Do you have it yet? Or
Yeah.
rolling credits here? All right, now. That website right there, I would like you to go to it. I don't know that you can get to it from here. Can we get to it from here? All right. I'll stay here. I'm just going to copy it. Oh, I'm going to have to go back to this document over here. My 8.2 notes. Where's my 8.2 notes? Some of you might have to actually paste it. I'm going to click. I'm going to go to it. Maybe you should just watch. Okay? All right, well, it looks the same. Sorry, I didn't program it. All right, now. You can see that as I bring these 2 points closer and closer and closer together, what's happening? What happens to the ellipse when I move them really far apart?
It gets narrow.
Okay.
And then
That's his finger.
I am. What happens when they get closer and closer and closer and closer? It gets more circular. In fact, when they sit directly on top of each other, if I can make that happen, you get a circle. Okay. Okay, now those dots, you just hold on a second, we'll talk about those. But I just want you to kind of visualize this idea that a circle is a special type of an ellipse. Okay, a circle is a special type of an ellipse. So when these 2 points get moved away from each other, you get more of that elliptical shape. These 2 points have a special name. Each one of them is called a focus. Together, they are foci. F-O-C-I, foci. Yes, it's a real word. Okay, like radius, radii, elvis, elvi, you know, when you have more of them.
I mean, the
Alright,
proper Latin pronunciation would be Foci for classical and Foci for medieval.
Okay, thanks.
Can we say Foci?
Okay, if you want to get thrown out of parties.
Foci.
Okay, so the foci of the ellipse are those 2 points. Now we're going to talk a lot about what's going on and why those 2 points are so special as it's moving. Now, I'll see if I can find a YouTube video for you, but if you would take a push pin and put it here and a push pin and put it there and put a string or a piece of yarn and then take a pencil and put it on the edge of that string and move it around. And as you would move it around, you would get this shape. Now that piece of string or yarn is not changing. It's still the same length. And that is the point of what I'm trying to get at. And we will talk about that definition. These 2 distances here, the orange one and the purple one, every time I stop and pick a point, the orange and the purple are different lengths, but when you add them together, you get the same number every single time. And that's how you actually define it. And let's see if I can find a quick YouTube. Don't worry about that. I mean, we could talk about that. Locus just means the whole set of points. What they just wrote out there was a definition saying that those 2 distances, the orange one and the purple one, added up to the same number every time. In fact, they actually add up to what we call the major axis. And so they're going to draw a line. It's not even perpendicular. Okay, never mind. Let's try not to be critical. Okay, let's see here. So they've got 2 points. They're calling them the foci, F1, F2. Okay, they've got their pins that they're going to, and they've got their piece of string that they're going to put in there, and they're going to tie it together so it's the same length. And then as they do this, I don't know, they must have had it redone or something. Evidently not. Okay, then we put the pen in and we keep it tight, and by doing that, they can draw that elliptical shape. Okay, so, and then they can highlight it. Oh, missed. Okay, shiny stuff. Okay, and so they're saying that the distance, if they take that distance and they add it to the other distance, which they're about to draw, they're going to get a particular value, and that particular value happens to be twice the length of the major axis. Now, if I go back to the other picture, we can probably, I wonder if I could pause the other demonstration. I wonder if I can. It won't let me do it, will it? Stop it. Stop it. Try it. I'm trying to grab it. All right, never mind. I can't grab it. You're right. Now, where's the orange one?
Oh, I found it, Mr. Staley.
Where?
Scroll up on the side, and then just click on click on the dot.
Click on the dot. Oh, there we go.
I don't know
Okay.
if you can like that. Yeah, you can. But I don't know how to make it play.
Okay, now, this will get me close. All right, if I actually take it out to the edge, it disappears on me. But if I was all the way out here at the edge, this orange piece right here could be moved over here and connected to the, so you would see that the purple, which is most of the major axis, and the orange would add up to the entire major axis. That's what they were trying to get at. Not at the moment. Okay. Okay. So, back to our regularly scheduled programming. So we have every ellipse has a center. Okay, now when we did our x minus h and y minus k, that was showing you the center, just like on a circle. So, h and k. We'll talk about finding the focus. Now, what do you think sits on the focal axis? Any guesses what sits on the focal axis?
Yeah.
Don't say foci. They're going to throw you out of parties.
The Foci.
Oh, my goodness. Foci. All right? So, you're right. The foci sit on the focal axis, which makes a whole lot of sense. Notice that the vertex, there are two vertices. They sit at the end of the major axis, also called the focal axis. They are all the way out at the outside edge. But this is that definition they were talking about in that particular video. PF1 plus PF2 equals twice 2a, or that is the definition of the major axis, which we'll talk about here in a second. Okay? So all those terms, which we've already discussed. Now, I need you to look. Now, wait a second. The reason I didn't really want to focus on this one is because this is really, really simple and basic. It's focused at the origin. Okay, I'm hoping that if you see that it's x squared and y squared and there's not x minus h and y minus k, I'm hoping that you know automatically that that's 0, 0. It shouldn't be that tough for you to look here and go, oh, hey, it hasn't been moved at all. The center is at 0, 0. Okay, the focal axis is horizontal. Well, okay. I do not like the fact that they are separating this into two sides. So I'm ignoring this side, and I'll tell you why. They like to say that a squared is always bigger than b squared. What that forces you to do is basically understand or memorize a few different formulas, and I don't want that. I want you focused on one set of formulas. So, for alphabetical purposes, a squared is going to sit underneath x, and b squared is going to sit underneath y. So when I ask you for a, you'll be taking the square root of the denominator underneath the x squared term. When I ask you for b, you'll be taking the square root of the denominator underneath the y squared term. The focal axis is not always going to be the x-axis. It will be sometimes when a is bigger than b, but when b is bigger than a, it'll be the y-axis. Because whichever one's longer forces the major axis to be that direction. So, and we'll look farther down here in a second. I never write the Pythagorean relationship the way they do. We typically write it like this: c squared equals the absolute value of a squared minus b squared. And we'll talk about that when we get into it. Your vertices may not be plus and minus a comma 0. In the vertical situation, it could be plus and minus b 0. Actually, no, that would be wrong. It would be 0 plus and minus b. Thanks for typing those notes out to a friend. Okay, so 0 plus and minus b. 0 plus and minus b. Okay, and likewise, your foci could also be 0 plus and minus c if it was a vertical, right, situation. Okay. we'll see more of that when we get to it. Okay, so example 1. First thing we need to do is we need to get this in a form where 1 is over on this side of the equation. So what should I divide this by? 36. Excellent choice. 36. So that would give me x squared over what? How many times does 4 go into 36? 9 times. How about 9 into 36? 4 times, thank you. And of course, you decided we were dividing by 36, so you better know that's 1. Now you should be able to identify things like the center. What's the center? Remember, we're looking for something like x minus h quantity squared plus y minus k quantity squared. But I don't see any of that stuff up there. 0, 0. Thank you very much. We just talked about that. Nothing has been subtracted or added to the x or the y before squaring. What's the a value? You're going to focus your attention there, folks, to answer this question. The square root of 9, right, or 3. How about b? The square root of 4, or 2. Now we're going to go ahead and graph this because you need to get comfortable doing that. Yes? Okay, you answered your own question?
Yeah.
Okay. I do that sometimes. I did it this morning. Yeah. Okay, now, center is at 0, 0. If A goes with X, do you think A should move left and right or up and down? Left and right. That is correct. So according to that, I'm going to go 3 units to the right and 3 units to the left. B goes with the Y, so it's going to go up and down, so that's 2 units up and 2 units down. Now, I'm going to draw an imaginary box. Folks, this is not actually a part of the ellipse, and man, I'm doing a bad job. Now, this particular imaginary box is going to help me in the future with the hyperbola as well as this ellipse. So I do need you to kind of get used to the idea of kind of getting this box in your mind. Now, where do you think the ellipse is in relationship to that imaginary box? Inside. Thank you very much. Try not to make it look like a diamond. Okay, give it a little bit of curve. I mean, try. I know I'm not an artist either, but try to give it a little curve. Okay. How about my vertices? We know that the vertices sit at the end of the major axis. Since the horizontal is the longer axis, then that one has to be the major one. So, what are the coordinates of the vertices for this? 3, 0, and -3, 0, right? Left and right. Now, if you would like to write it like this, I'm okay with that. If you want to write them out separately, you can. Because it looks like it's right on the x-axis. 3 to the right, 0 up. 3 to the left, 0 up. Okay. All right, now. It's also asking me for the foci. So we need to look at that relationship. C squared equals the absolute value of A squared minus B squared. Basically, folks, you're going to take the 9 and the 4 and subtract them. And it doesn't matter whether you put the larger one first or the smaller one first, because you're going to take an absolute value of it, right? So, it doesn't matter. And so we get 5 there. What is the value of C? If C squared is equal to 5, yes. Well, we did it technically, but remember, this is A squared. And this is B squared. So I already had them, 9 and 4. I'll take a radical. Radical 5, good job. Radical 5 is approximately what, 2.2 something?
It's 2.2.
Okay. Radical 5 is about 2.2, so somewhere right in there. This distance is radical 5. So these two locations are my foci, like F1 and F2. We just found it, didn't we? We used the Pythagorean identity. Well, it's a modification of the Pythagorean identity. So, what are my foci? Okay, you didn't give me the actual coordinates. We showed you where they were on the graph. Radical 5, 0 is one of them. Negative radical 5, 0 is the other one. How can we say that like all at the same time? Ooh, plus minus radical 5, 0. You can separate them. You can write radical 5, 0, and then in the separate coordinate, write negative radical 5, 0. Is that what you meant? Or did you have some other ingenious idea? Okay. All right. Yes, you can write them separately. Now, take a look at the picture on the left. Do you see how they used A to come out here to the right and A to come out here to the left? They used A in the horizontal direction. They used B in the vertical direction to come up and to come down to find the edges of their box. They found C and they used that to find the distance to each one of the foci. Here's what I don't like about the way the book handles this. If you look at the picture on the right, what did they do with... Oh, by the way, the one thing I do like about this picture is that they show you the relationship. What they did was they took this distance right here that I'll put in blue, which we called A, and they showed you that if they connect it from the tip of C to B, it forms that hypotenuse of the right triangle. So that's why they get B squared plus C squared equals A squared, but we modified that. We modified that by putting this term on the other side. What I don't like about what the book does is if you look at the picture on the right, they switch A and B. I do not like the fact that they do that. They want to claim that A is always bigger than B. I think, after watching years of kids do this, that you're much better off if you just stick with A being underneath X and B being underneath Y. That way you always know that A goes left and right and B goes up and down. So don't get caught up in looking at and switching A and B. It doesn't help you. Example 2. Finding an equation and graphing. Well, we've already kind of got or talked about graphing a little bit, but it says find an equation of an ellipse with foci at 0, -3. All right. 0, -3. So we got focus number 1. And 0, 3. Focus number 2. Do you know right now whether this is going to be a short, fat variety or a tall, skinny variety? This one's going to be tall and skinny. You're right. Because the foci sit on the major axis. Right? Sit on that major axis. So in our minds, this is a very poorly drawn sketch, but we have this idea in our minds that it's going to be going up and down. Okay? It says that the minor axis has length 4. The minor axis. That would be edge to edge. Edge to edge. So how far left and how far right should I go? I should be going 2 left and 2 right. That would be a distance of... So I know I'm going to be stopping there and stopping here. So do you know the value of A? By looking at the picture, can you tell me the value of A? It's 2, isn't it? What would you have for A squared? 4. How about the distance to the focus? We call that C. Does anybody know what C is? 3. C is always your distance to the focus. Distance to focus. If I didn't mention that enough, that's what it is. We should probably have enough information to find B. Since we know that C squared equals the absolute value of A squared minus B squared. All right, so what would you have over here on this side? 9. What do we have for A squared? 4. Okay, figure it out. Figure out what B squared is right now. Absolute value means distance away from. So can you think of something that's 9 units away from 4? 13 is correct. B squared is equal to 13. Okay? Because if you take 4 minus 13 and take its absolute value, don't you get 9? 4 minus 13 isn't it? Right? The absolute value of that would be 9. How did I do that? I understand that absolute value means distance away from. So I'm trying to find something whose distance away from 4. So if you think about if you would think about a number line and you got 4 here, we need something that's 9 units away from 4. So it would have to be 13. Yes, we added 4 and 9. You are correct. Plus, if you think about it, when you plug 13 back in, 4 minus 13, take the absolute value, you do get 9. Now, What does that give me for B? B equals radical 13. Mr. Beaujolais, how much is that approximately? Let's see what we got there. 3.6. Okay, so this is approximately 3.6 units. Which means that the edge is there and there. Notice how I went 3.6 units up and 3.6 units down to find the edge of this box. Where do you think that ellipse will be in relationship to this imaginary box? Inside of it. Write me the equation. Oh, by the way, what is the center of this? We should have identified that a while back. The center, 0, 0. Okay, write your equation. I'll give you about 30 seconds to do that since you've got all the pieces you need. X squared over what? 4 plus y squared over what? 13 equals 1. See, we had all the pieces we needed. Yes.
So do you not have to write it like the one above, which is 4x squared plus
No, we don't need to. Okay. In fact, I mean, we can do that, but what I would end up doing is multiplying everything by the common denominator, which would be 4 times 13 or 52. I could do that, but I don't need you to. Okay? The form you're describing is called general form or close to general form. This is called standard form. Okay? I would prefer that you give it to me in standard form. So ignore that side. This is more generically speaking, because you can see the center has been changed. It is no longer 0, 0. Although, you know, if h and k are both 0, 0, it turns into the other form. No big deal. We'll be careful on some of these things, because whether they're vertical or horizontal, don't get hung up on. This is why I'm graphing these pictures out. It's because I want you to see, oh, we go up this much and down this much and left this much and right. Graphing, thank you very much. It's important to see the picture. Find the standard form of the equation for an ellipse whose major axis has these endpoints. So since it's the major axis, what's special about those 2 points? What do we call them at the end of the major axis? Vertices, right? These are my vertices. You can see that they have graphed them out for us. You can also see that they told me, we looked at the minor axis as length 8. Since they have identified the vertices as horizontal, we know this is going to be the short fat variety. They graphed them. You might not, so that's why I'm trying to tell you graph, 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 graph. Okay, so that you get it into your minds that you need to graph. Okay, what's the center?
3, -1.
It is 3, -1, that's true. You can tell because it's halfway between the 2 vertices. That is also where the minor axis cuts through. You can see that they've drawn that. Now, why did they go 4 above and 4 below the center? Because we know the minor axis length has 8, so we cut it in half. So what's the value of B? 4, good. What's the value of A? I got to vote for 5. Is that true? From 3 to 8, is that 5? That is. How did we get B? We counted. They said that if the minor length was, or axis length was 8, then we had to split it in half. Go up 4 and down 4. Do we have enough information to write the equation? They didn't even ask me for the foci. Yeah. So, what do you got in this set of parentheses for x? Come on, center, center, center. X minus 3 over a squared. What's a squared? 25, exactly. Right? We wanted a squared. Plus, what's in the other parenthesis? Y plus 1, quantity squared, over 16. Nice job with the b squared. Equals 1. Good job. You get it. You got it. Okay, then now they didn't ask me for C, and if you want me to talk more about that, I can. We can find. Let's do that with our last remaining minute here. So tell me, when I look at this, what do I use to determine the focal distance? Come on. Right here they are. Thank you for staying with me. What do you get? 25 minus 16. 9. The absolute value of that's 9. So what do you got for C? 3. Therefore, we know. Tell me what the foci are. Which way do I go? Left and right or up and down? Left and right, because we have to follow the major axis, don't we? That's why I don't want to get hung up on formulas when I need to understand what the picture looks like. There's one focus, and here's the other one. So, what are those coordinates? 0, negative 1 is one of them. Come on, right here it is. I got a 6, negative 1, and that is true. Folks, there's no plus and minus that you can use here. You do need to write them out. 0, negative 1, comma, 6, negative 1. Yes, what's the question while they go to lunch? How did I get what? Okay. So, we used the distance, 3, and we walked 3 units to the right along the major axis. If the major axis had been vertical, we would be going up and down. But because the major axis was horizontal, we're moving left and right 3 units. Yep.